Hiyo, this is Ade from Ailaon Academy, and I saw this interesting video on Khan Academy where he solved a coordinate problem based upon line segments using ratios. I present to you an alternative solution which instead uses vector line equations. I hope you find it instructive. So, the problem statement tells us that point A is minus 1, 4, point C is 4 minus 6, and we are being asked to find point B somewhere along this line AC, such that the ratio between AB and AC is 3 to 5. Now I've written AB and AC as vectors because my general solution involves thinking of this problem in terms of vector mathematics. So the first thing that we're going to do is remind ourselves what a straight line is. Now the equation of a straight line is y equals mx plus c, okay, where I have my solution, which is y, I have my gradient, which is the direction in which I'm going between points along that straight line. I have my variable, which is the step which I'm taking along the line, and I have my y-intercept, which is where the line crosses the y-axis when x equals 0. Okay, now if we were to translate this into a vector line equation, it would look a little different because we would be using vectors in this case. So, but the vector line equation is still based upon the standard y equals mx plus c straight line equation. I have my L. Now L is my solution, which gives me a point in space. And to get to any point in space, I need to start from somewhere. So these are my initial values. I need to start from somewhere on that line. This is usually the first point on the line. In this case, it would be A. I've chosen A as my initial vector point. I go in a certain direction, and that's what I've given as xn, yn. And I go in a certain step in that direction, and that's the symbol lambda that I've given as the step in direction. So to go from my initial value x0, y0 to any point, to any vector point along the line, I need to take a certain amount of steps in this direction. And that's the essence of a vector line equation, which works in 2D and 3D space. So let's try it out just for AC by itself. Okay, so the direction of AC in vector format is going to be the point C minus the coordinate C minus the coordinate A, and that's simply 4 minus 6, which is the coordinates of C, minus 1, 4, which are the coordinates of A, and we get the direction of our vector line 5 minus 10. Okay, so this entire line is moving in a direction of 5 minus 10. Okay, so let's see if we can use this direction 5 minus 10 to get from A to C. Okay, now this represents one step. To go from A to C, I go one step in 5 minus 10. So 5 along the x minus 10 along the y. So I substitute in my values into my vector line equation. So my initial point is minus 1, 4, which is A. So this is A, and this is my step, and this is my direction. Lambda equals 1. I do the arithmetic, and I get C. Okay, so this checks out. I'm just confirming that this equation makes sense and is true. So now we can extend it to this problem here. Find B such that AB, the vector AB, to the vector AC is equal to 3 to 5. Okay, so B lies somewhere along the line. Okay, it's somewhere along the line. Okay, but we don't need to be searching all along the line. We only care that B is 3/5 along the way to C. So from A to C, B is 3/5 along the line. Okay, because the vector AB is only worth 3/5. And then the vector from B to C would be 2/5. And then that would make up the entire line. So we go back to our vector line equation and we set lambda equal to 3/5. I'm expecting that if we step 3/5 in the direction, we will end up at B. So I plug in the values. I start at A. So I start at A and I go 3/5 in this direction. And I'm left with this summation of vectors. So -1 plus 3 in the X, 4 plus -6 in the Y. We add those up together and we get our final point B, which is 2 minus 2. And this is the exact same answer that Khan Academy got. So I hope this video was educational, and I implore you to try it out for yourself and to read up on vector line equations yourself. They are very, very useful and they can help us solve a wide variety of problems in 2D and 3D space.